Hi. This video we're going to discuss the operation of a diode laser. In my case it's a 20 watt power consumption 5.5 watt optical using the RNR USB Mach3 controller board. I am using a custom screen set for Mach3. I've created custom post processors which are used with Aspire, and for the side I have also created labels for the hotkeys tied with Mach3 for easy operation. Here is the wiring diagram I have used on my CNC machine successfully. My machine has been running now for more than 2 years without any electronic failures, all successful. The RNR controller, the pin outs regarding the laser output, let's take a closer look at that. As you can see on the top row of connectors, we have a 10V. We have just below that the AVI and the ACM. Those three pins are going to be directly related to the PWM output for the laser and or spindle speed. There is a bit of confusion regarding the operation of this. The labeling on the board I personally feel could have been done better, but it is sort of tied together with the standard markings on a variable frequency drive or VFD for spindle use. On the VFD drives, the standard operation would be with an external potentiometer, more referred to as an analog input. So that's why they are labeled ACM, being an analog common. The AVI is an analog variable input, referring to the input of the VFD and not the input of the Mach controller, as this is actually an output. And the 10V is referenced as or referred to as a reference voltage. The 10 volt is again labeled as the VFD output, voltage output. If you have a laser, in some case, because this is what we are trying to get working, if you have a laser that is working with a 5 volt TTL or PWM input, then you would put a 5 volt reference voltage on that particular pin. So that should rather be labeled as a reference input rather than 10V. However, if your laser is a 12 volt operation, you can then apply 12 volts to that pin. And the same power supply used for the laser, let's assume it's 12 volts. 12 volts will go to the 10V on the board. The ground or negative of the power supply will go to the analog common, and the AVI, analog variable input, is actually the input of your laser driver board, which is in the PWM. So the labeling on this board is rather confusing, but if we just keep in mind that this was more designed to be working for a spindle and not the laser. Let's go back to the wiring diagram. Let's see if we can get a better picture on that. Okay, so the wiring which is displayed between the actual laser unit and the driver board is a standard cable that fortunately came together with my laser as I bought it. So those pins are not labeled, as there's no need for that. It plugs directly from the laser to the driver board. The 3 pins that we need to concentrate on will be the ground, the 12 volt, and on this particular laser driver board, the PWM is labeled as TTL. I've tried to color code the wiring for better visual reference. I do hope it is visible. I will attach a link to this image below so you guys can access and download it at your own discretion. So as you can see, the 12 volt for the power supply goes to the 10V on the board. The AVI is the PWM output, which goes to the laser driver board, and the ACM, which is common, I have tied that together with the DCM, which is the digital common. Fortunately, I'm using one power supply for all my devices, so this works quite simple. If you are using a alternative power supply, I do not recommend tying the commons together, as it can create a ground loop and other interference. So I do recommend put a meter between them and actually check that they are one of the same. Okay, back to the larger drawing. I'm not going to go through the wiring on the stepper drivers, as I would assume you guys are familiar with that. The micro switches on the drawing just indicate the homing for X, Y and Z. The first micro switch is for the Z probe, which I do have active on my machine. The method of how my system works, I have the Mo3 command, which is pin 1 on Mach3, or output pin 1 on Mach3, which drives my spindle. Using a palm router type spindle, only operates in one direction. On the Makita, and I think on 1 or 2 other machines, it has a variable speed on the actual machine, which allows you to do that at your own discretion, but does not have a counterclockwise operation. Therefore, the Mo4, which would have been used for the counterclockwise spindle operation, I use that to switch the laser on and off, which is the Mo4 command that's wired to my I think it's wired to output 3 in this instance. I have also got the dust extraction unit, or the vacuum wired into the MO7, which is output 2 at the time when this diagram was drawn. I have in the interim added in a air assist for the laser, which has a solenoid and cutting fluid, which can also be used for mist when I cut soft metals with the router, being aluminium, copper, brass, and those sort of things. So on the newer diagram, which I will still have to put together, this page is a bit small, so we'll have to see where we squeeze it in. I'll have to add in the fourth relay with the other function. Okay, here is my Mach3 custom screen set. As you can see, there are a couple of changes I've made. On the far right hand side, I have added in the label spindle laser. The buttons work directly in conjunction with the operation, so if I were to click on the spindle button, it will switch the spindle on or toggle the spindle on or off. If I were to click on the laser button, it would toggle the laser on and off. If we were to change the RPM or power output, the PWM output, the laser's intensity will either increase or decrease. The incremental value on my laser is minimum 10. At that point it does not switch on or have an illumination on the laser, and if it's at 1000, the laser is then at 100% operation. So the displayed value is multiplied by 10. On the left hand side, as you can see, the labels there have been changed. I think the original labels read flood and the other one mist. In my instance, I've changed it to a vacuum, and the other one is air mist. Just depending on what we are using, the machine can automatically switch these things on. So if I do use the spindle and I am doing cutting of wood, the vacuum comes on automatically. It's not something I have to do on the side. Mach3 controls that for me. And the same operation when I use the air assist as well. Okay, here's the spindle ports and pins that we will be using. As you can see, the clockwise output, which is MO3 or M3 as displayed, is my output pin 1. Counterclockwise is MO4 or M4 as displayed, which is on output pin 3. That enables and disables the laser. mist operation, which is M7, would be my air mist assist, and the flood, which is MO8 or M8 as displayed, switches the dust extraction vacuum on and off. The shortcut keys on my keyboard, just for easy operation, I've made up some labels which I've applied to the keyboard. Unfortunately on this image it's not exactly clear. That just gives a general idea of how they look. That should be a bit of a clearer indication of what we've done, as some of the shortcut keys are not, don't always remember what they are, so just having the labels in place just keeps things simple. Okay, let us move to Aspire and let's do a quick drawing. Okay, I have already prepared something for the demonstration. I'll be making a keyring. I've just found a vector on Google of an old VW bug, but what I have done is on the first profile toolpath, as you can see, the inside highlighted in purple is the bug. The laser is going to be engraving that on the material that we will choose today, which is going to be an acrylic substrate which is laminated with aluminium on the top and the bottom. The aluminium is then coated, which appears to be powder coated or some form of a epoxy enamel something. The data sheet from the suppliers is quite vague on exactly what they've done with it, but on the coated side of the aluminium, the laser can engrave or burn the coating away, which leaves the aluminium quite visible. The color of the material is black, so it comes up quite nice. And then what we're going to be doing is, once the laser has completed that task, we will then move over to profile 2, which is in the cutout, which the spindle will be doing for us. I will be using a 3mm 2 flute bit to do the cutout. What we will do is, let us do a visual on the end product of what we will be expecting. Okay, let us go to the 3D view. Let us play those toolpaths again. So that's laser, that's the cutout, and hopefully we will have an article that looks something like that. So profile 1, which is the laser, we save that. For this particular operation we'll be using my offset laser post processor as the spindle and the laser obviously have an offset. They are both mounted to the same gantry, and we can then do the other one as a standard aux, and we'll save that as the cutout. Now off to the CNC machine. We are loading the laser file, so you can see I'm using a touchscreen display. Holding the cell phone doing the recording is slightly disorientating. Just get the folder open, select the laser file, and there we have it, it's loaded. Okay, you can see where the crosshairs are. That's the offset of the laser. Cycle start. Okay, there we go, cycle start. And there she goes, offset, laser begins. Okay, this is going to take a few minutes, so I'm going to do this at double speed. Once this is complete, we will then do the cutout with spindle. Okay, this is almost done. As you could see, the laser power set at 35%, displaying 350 earlier on. Right, once this is done, we will then do the cutout. Okay, so let us select the cutout file for spindle. File loaded. You can see now our crosshairs have gone to the center of the drawing. Cycle start. Okay, this cutout works in a single pass straight through cut. I've not put tabs on this particular drawing, so I will have to just hold on to it so that it doesn't get thrown around. Please guys, don't try this at home. And there we go, done. Let's just check that it's actually loose. Yeah, there we go, it's all cut loose. Let's get the spindle out the way. And there we have it. 1 VW bug keyring.